In this video, I'd like to tell you how to write control statements for your Octave programs. So things like for, while, and if statements, and also how to define and use functions. Here's my Octave window. Let me first show you how to use a for loop. I'm going to start by setting v to be a 10 by 1 vector of zeros. Now, here's how I write a for loop. For I equals 1 to 10, that's for I equals 1 colon 10, and let's see. I'm going to set v of I equals 2 to the power of I, and finally end. The white space doesn't matter, so I'm putting the spaces just to make it look nicely indented, but the spacing doesn't matter. But if I do this, then the result is that v gets set to to the power 1, to the power 2, and so on. So this is syntax for I equals 1 colon 10 that makes I loop through the values 1 through 10. And by the way, you can also do this by setting your indices equals 1 to 10. And let's look at indices. This is an array from 1 to 10. You can also write for I equals indices. And this is actually the same as for I equals 1 through 10. So you do display I end, and this will do the same thing. So that was a for loop. If you're familiar with break and continue, that's break and continue statements, you can also use those inside loops in Octave. But first, let me show you how a while loop works. So here's my vector v. Let's write a while loop. I equals 1. While I is less than or equal to 5, let's set v I equals 100 and increment I by 1. End. So this says I starts off equal to 1, and then I'm going to set vi equals 100 and increment I by 1 until I is greater than 5. And as a result of that, whereas previously v was this powers of 2 vector, I've now taken the first 5 elements of my vector and overwritten them with this value 100. So that's the syntax for a while loop. Let's do another example. I equals 1 while true, and here I want to show you how to use a break statement. Let's set v I equals 999 and I equals I plus 1 if I equals 6, break, end. And this is also our first use of an if statement. So I hope the logic of this makes sense. It says for I equals I equals 1 and infinite loop, while repeatedly set vi equals 1 and increment I by 1, and then once I gets up to 6, do a break which breaks you out of the while loop. And so the effect of this should be to take the first 5 elements of this vector v and set them to 999. And yes, indeed, we've taken v and overwritten the first 5 elements with 999. So this is the syntax for if statement and for a while statement, and notice the end. We have 2 ends here. This end here ends the if statement, and the second end here ends the while statement. Now let me show you the more general syntax for how to use the if-else statement. So let's see, v1 is equal to 999. Let's set v1 equals to 2 for this example. So let me type if v1 equals 1, display the value is 1. Here's how you write an else statement, or rather here's an else if v1 equals 2. This is going to be the case that's true in our example. Display the value is 2, else display the value is not 1 or 2. Okay, so that's a if else statement hit end, and of course here we've just set v1 equals 2, so hopefully it displays that the value is 2. And finally, I don't think I talked about this earlier, but if you ever need to exit Octave, you can type the exit command. If you hit enter, that will cause Octave to quit, or the quit command also works. Finally, let's talk about functions and how to define them and how to use them. Here's my desktop, and I have predefined a file, or pre-saved on my desktop a file called squarethisnumber.m. This is how you define functions in Octave. You create a file called, with your function name and then ending in .m. And when Octave finds this file, it knows that this is where it should look for the definition of the function square this number.m. Let's open up this file. Notice that I'm using the Microsoft program WordPad to open up this file. I just want to encourage you, if you're using Microsoft Windows, to use WordPad rather than Notepad to open up these files. If you have a different text editor, that's fine too, but Notepad sometimes messes up the spacing. If you only have Notepad, that should work too. That could work too. But if you have WordPad as well, I would rather use that or some other text editor if you have a different text editor for editing your functions. So here's how you define a function in Octave. Let me just zoom in a little bit. And this file has just 3 lines in it. The first line says function y equals square this number x. This tells Octave that I'm going to return a value y. And I'm going to return one value, and that value is going to be saved in the variable y. And moreover, it tells Octave that this function has one argument, which is the argument x. And the way the function body is defined is y equals x squared. So let's try to call this function square this number 5. And this actually isn't going to work. And Octave says square this number is undefined. That's because Octave doesn't know where to find this file. So as usual, let's use pwd. Oh, I'm not in the right directory. So let's cd users ang/desktop. That's where my desktop is. Oops, little typo there. Users ang desktop. And if I now type square this number 5, it returns the answer 25. As kind of an advanced feature, this is only for those of you that know what the term search path means. But so if you want to modify the Octave search path, and you could just think of this next part as advanced or optional material, only for those of you that are familiar with the concept of search paths in programming languages. But you can use the term add path, say c:/users/ang/desktop, to add that directory to the Octave search path, so that even if I go to some other directory, I can still Octave still knows to look in the users ang desktop directory for functions, so that even though I'm in a different directory now, it still knows where to find the square this number function. Okay, but if you're not familiar with the concept of search paths, don't worry about it. Just make sure to use the cd command to go to the directory of your function before you run it, and that should work just fine. One concept that Octave has that many other programming languages don't is that it can also let you define functions that return multiple values or multiple arguments. So here's an example of that. I've defined a function called square and cube this number x. And what this says is this function returns 2 values, y1 and y2. I'm going to set them as follows. y1 is squared, y2 is x cubed. And what this does is this really returns 2 numbers. So some of you, depending on what programming languages you use, if you're familiar with C, C++, Java, often we think of a function as returning just one value, but this whole syntax in Octave lets it return multiple values. Now back in the Octave window, if I type a, b equals square and cube this number 5, then a is now equal to 25 and b is equal to the cube of 5 is equal to 125. So this is often convenient if you need to define a function that returns multiple values. Finally, I'm going to show you just one more sophisticated example of a function. Let's say I have a data set that looks like this with data points at 1, 1, 2, 2, 3, 3. And what I'd like to do is to define an Octave function to compute the cost function j of theta for different values of theta. First, let's put the data into Octave. So set my design matrix to be 1, 1, 1, 2, 1, 3. So this is my design matrix X with X0, the first column being the intercept term, and the second term being my the X values of my 3 training examples. And let me set Y to be 1, 2, 3 as follows, which were the Y-axis values. So let's say theta is equal to 0, semicolon 1. Here on my desktop, I've predefined this cost function j, and if I bring up the definition of that function, it looks as follows. So function j equals cost function j, input is x, y, theta. some comments specifying the inputs, and then via a few steps, set M to be the number of training examples. That's the number of rows in X. Compute the predictions. Predictions equals X times theta. And this is a comment that's wrapped around. So this is part of the preceding comment line. Compute the squared errors by taking the difference between predictions and the y values and taking element y squaring. And then finally computing the cost function j. And Octave knows that j is the value I want to return because j appeared here in the function definition. Feel free, by the way, to pause this video if you want to look at this function definition for longer and kind of make sure that you understand the different steps. But when I run it in Octave, I run j equals cost function j x, y, theta. It computes, oops, made a typo there, should have been capital X. It computes j equals 0 because if my data set was, 1, 2, 3, 1, 2, 3, then setting, right, theta 0 equals 0, theta 1 equals 1, this gives me exactly the 45-degree line that fits my data set perfectly. Whereas in contrast, if I set theta equals, say, 0, 0, then this hypothesis is predicting zeros on everything. This is saying theta 0 equals 0, theta 1 equals 0, and I compute the cost function, then is 2.333, and that's actually equal to 1 squared, which is my squared error on the first example, plus 2 squared, plus 3 squared, and then divided by 2m, which is 2 times number of training examples, which is indeed 2.33. And so that sanity checks that this function here is, computing the correct cost function, at least in the couple examples we tried out on our simple training example. And so that sanity checks that the cost function j, as defined here, that it is indeed, seeming to compute the correct cost function, at least on our simple training set that we had here with x and y being the simple training example that we saw. So now you know how to write control statements like for loops, while loops, and if statements in Octave, as well as how to define and use functions. In the next video, I'm going to just very quickly step you through the logistics of working on and submitting problem sets for this class, and how to use our submission system. And finally, after that, in the final Octave tutorial video, I want to tell you about vectorization, which is an idea for how to make your Octave programs run much faster.